let's go through two examples finding confidence intervals. And going through, it's going to be a three-step process that we go through for these. So we have this poll that asked 166 adults whether they were baseball fans. 48% said that they were. So what we have here is our sample size. So we have a sample size of 166. And we're looking at the proportion of U.S. adults that are fans. So this 48% is going to be the idea of our sample proportion. Since it's coming from this poll, that's going to be our p-hat value of 0.48. And then again, if you're finding p-hat, just go ahead and find q-hat as well by taking 1 minus that value, which is going to be a 0.52. So that's the information we get out of that sentence. First thing we want to do is construct a 99% confidence interval for the true proportion of U.S. adults that are baseball fans. So we're going to try to extend it from where we have this for 166 adults, what percentage is true for all U.S. adults. And with that, we're going to use this as our best estimate and create an interval around it. Before we do anything, we have to check conditions. So first things first, checking our conditions. So, making sure we have independence in our sample. So, for us, that the result of one person doesn't influence the other, or we can use that 166 U.S. adults is less than 10% of all U.S. adults. So that's going to be okay. Randomization, ideally, it should say that they asked 166 random adults. It doesn't say that, but we're going to go ahead and assume, so we'll be okay there. And then where we need to actually do the math is with the sample size condition. So taking that 166 times 0.48 and taking that 166 times 0.52 and making sure they give out large enough values, which this will be about 77, this will be about 86. And, sorry, let me just double check those one moment. 166 times 0.48 is going to be, sorry, that should be about 80. There we go. A little trick I use there is that these numbers should always add up to your sample size. So that's where I did some quick mental math and noticed that wasn't true. This isn't a vital calculation, but that's something you can use, that those combined should always make your sample size. So those are both more than or equal to 10, so we're good. So we have to go through that because if we fail any of those three conditions, we can't move forward because we have to use the bell-shaped curve for this. Our next step is to construct the interval. So this is where we actually use our formula. So, I'm just going to write down our formula that we had on the previous page, taking our sample proportion plus or minus z star times our standard error, which is p hat times q hat over our sample size. So our sample proportion, that's our 0.48, so I would plug in right there, plus or minus z star. So since we're using a 99% confidence interval, we don't need to go calculate it again. Since we already did it in the previous video, z star should be 2.5758 since that's specific to the 99% confidence interval. So that's going to be our z star value. So that's what we'll plug into our calculation right here before our square root of taking p hat, which was 0.48, times q hat of 0.52, divided by our sample size of 166. And what we're going to want to do for our next step is, again, simplify this right-hand side. So where you'll still have 0.48, you'll still have plus or minus. For this right-hand side, you'll want to go ahead and throw in everything into the calculator at once, just to avoid any rounding errors. So taking that 2.5758, and then that's going to multiply the square root, and then just make sure everything's under that square root symbol. of that 0.48 times 0.52 over 166. So the only thing that should be outside of the square root is that 2.5758. And with this, we can round to 4 decimal places, and that'll tell us what we're going to be adding and subtracting by. So now we can split into the two scenarios, the one where we subtract and the one where we add, to calculate our lower bound, which is going to come out to 0.3801. And then when we add, we get our upper bound, which is a 0.5799. So that gives us our actual interval. But whenever we make an interval, we always have to end with a conclusion. And that's our third and last step. Writing up an accurate conclusion in sentence form. So remember, we want to mention our confidence level, our range of values that we just calculated there, and then talking about this proportion of all U.S. adults that we're extending this to. So starting with our confidence level, we are 99% confident. So since we use that z-star value to go with 99%, that's our confidence level. We are 99% confident that 38.01% to 57.99% of all U.S. adults are baseball fans. And that sentence contains everything we need for an accurate description of what we found. So those are the 3 steps we should go through every time we construct and interpret a confidence interval. Let's do that again, but we're going to change our confidence level down to 80%. So going through our 3 steps, we should check our conditions, which actually checking the conditions isn't going to change. So since we passed them in the first example, that's just going to be the same there. So let's go ahead and skip over that. Then let's construct the interval, and this is going to change a little bit. So our sample proportion is still 0.48. We still have plus or minus, but what's going to change is z-star. When we have 80%, that's where we want to go to this scenario where z-star should be 1.2816. So we should be plugging in 1.2816 right here to multiply with that standard error of 0.48 times 0.52 over 166, all underneath the square root. So what this is going to change is our margin of error. Where we had this margin of error of 0.0999 here, it's based on that 99% confidence level. Here, because we change our confidence level, it's going to change this margin of error on the right-hand side. And when we calculate all of that out, we should get out a 0.0497. So adding and subtracting that, when we subtract, we should get a 0.4303. And when we add, we get a 0.5297. So for our conclusion, it's going to be worded very similarly, just some numerical values change. We'd say we are 80% confident that 43.03% to 52.97% of all U.S. adults are baseball fans. So we get this interval for the same idea coming from the same sample data. All that changed is our level of confidence. So what we want to notice here is what changed with our interval. And with that, we're going to talk about the difference between certainty and precision, which certainty is the idea of our confidence level. Precision is kind of what's happening with the length of our interval. So if we think about the distance our interval is covering, if this is covering from 0.38 all the way up to 0.58, you can get this idea of a large distance being covered, and this is a smaller distance being covered. So with that, when we bring down the confidence level, we get a smaller interval coming through. And then when we have a large confidence level, we cover a long distance. And the idea is that this confidence level, it's like this 99% confidence that we are capturing that true value, that actual population proportion. So if I want to be super confident that I'm capturing the population value, we need to cover a large distance, because then it's more likely to be within that range. I've heard an example where it's kind of like if you're fishing. If I want to get on that boat and say I'm 99% sure I'm going to catch a fish, if I was bringing a net with me, I would bring a huge net. It's like we're casting this large net to be more sure that we're capturing the true value. Whereas if I go fishing and save and bump this down, maybe I'll be like 20% confident I catch a fish, and that likely it's not going to be in there. Maybe my net would be tiny. It can be a tiny net because I'm okay with missing it. I'm more okay with missing it than in the level where I'm more confident. So with that, the size of the confidence interval, if we're more certain, so the higher the confidence level, the larger the interval is. So the interval is larger with higher confidence. Because with higher confidence, we want to be more sure that we're grabbing it, so with that we have to extend the interval. And then when we lower the confidence level, the interval is smaller with lower confidence. So if we're not as confident about capturing that population value, we can have a short little interval with limited values in there because it's okay that we're missing it. So this comes through with our different confidence levels that we have. What I'm going to do in the next video is go through how to find these intervals with technology. In terms of the work that we show in the class, we always want to go through this information, but we can use technology to double check these intervals that come out.